It's a pleasure to be here. I'm going to zag a little bit. Will asked me to talk about how we should be thinking about additive in terms of production and how you can incorporate it successfully into your businesses. And so I'm going to take a step back and go up to the 10,000-foot view and really talk a lot about the economics and, again, how you should be thinking about additive and why. All right, and so just by way of background, right, at Proto Labs, we're an on-demand manufacturer, and we offer 4 different manufacturing services to our customers. We have injection molding, CNC machining, sheet metal fabrication, and additive. And we're supporting customers across a wide range of industries. And so we engage a lot around which manufacturing technology are best for those customers' parts and projects at the time. But I think we have to acknowledge that those decisions are not getting made in a vacuum, right? There are a lot of factors and trends that are impacting product development today. And first and foremost is just the sheer pace of new products and introductions that are required. The days of products generating profit as a cash cow for years to decades on end are quickly coming to an end. I would imagine, Brian, you're seeing this in the aviation industry, autos facing this. The life cycle of products are just shrinking. And the new products that are coming in their stead are being demanded by the customers to be far more personalized and far more customized. So we're getting more products that are required, and they're more complex. And those products themselves and the equipment that they're made on are more and more connected. I mean, that's the reason that we're here. This same SAP report that I'm referencing on this third bullet, talked about it estimated 25 billion IoT devices installed by the end of last year. That's 3 times the number of people on our planet. That's staggering. And so the sum of this, right, and it goes right into what Brian was showing, is that manufacturing has to change. It has to change. It has to be more efficient. It has to be faster. It has to enable you to get your products to market much quicker because the window of opportunity to take advantage of that revenue stream is ever shrinking. And so one would think that additive, being inherently CAD-based, being inherently fast, is an ideal fit and, in fact, uniquely positioned to be a part of this new digitally enabled end-to-end manufacturing system that's required to support all of those product trends that we talked about on the last slide. And so the natural question is, well, is 3D printing, is additive ready for prime time? Is it ready for production? And I think in answering that, we have to step back and talk about where additive is in its journey to industrialization, right? So let's start with reminding ourselves of injection molding story, right? So injection molding comes on the scene in the late 1800s. And its first materials were actually celluloid. And it's used in combs, and then it evolves to records, but it remains really niche, right? And then in the early 1900s, we start seeing lab-synthesized plastics. We see additives. Some of the materials that we're familiar with today, polyethylene, nylon, they come on board. And see the first screw extrusion machine come on board. And then World War II happens, and there's a massive spike in demand. And then from that point on, there's no looking back. Right, by the 1980s, plastics overtakes metals, and today it's this near $300 billion behemoth that we know and work with today, right? And so it's important to understand that, right, because it took a combination of machine, material, and application to really create that tipping point, right? And as we all know, right, additive is on that journey today. And so, you could argue, we kind of did some research, and sort of the first application of a laminate-based technology that we found was actually map making way back in the early 1800s, right? They would glue successive layers of elevation together and you get kind of a 3D representation of the topography, right? So that's a fun fact, okay? But we can't even begin to talk about the industrialization of additive until the 1980s. I think both Brian and Andy referenced this, right? That's when the patents of all the technologies that we know today came into play. So all of FDM, stereolithography, all the systems that, Will was talking about, those start in the 1980s. And they've been the bedrock of growth that have built the industry over the last 30 years. But if you think about that, that's extremely young compared to where injection molding is and has been. Now, by no means am I arguing that we're saying, it's another 20, 30, 40 years to the tipping point for additive. The world moves way too fast for that today. And the case in point, I think Andy referenced it, right, is early in the last decade, right, when the patents of FDM expire, and there's this explosion of the maker space. And yeah, it did do a little bit of damage to the industry in terms of the Gartner hype cycle and how people think about it. But what it did do is drive an interest, right, and drive a lot of engineers to explore how they could incorporate additive. And they have, right? And so the raw answer to, is additive viable for production? It's yes, right? Brian just showed you some applications. I mean, additive is in use today. It's in airplanes, it's in homes, it's on manufacturing floors, it's in human bodies. But I think we in the industry would have to stand back and say, it's not as prevalent as it should or we would like it to be. And so, that begs the question as to, well why? Well, let's follow the money, right? Because if we're talking about a choice of different manufacturing technologies to use, we're having an economic discussion, right? Which offers the best business case and how you should think about it, right? Now, a business case could either be an enhanced cost, right, on a part-for-part basis. One has a cost advantage, or like you've seen in some of the examples before me, one technology may enable you to do something, a product, a system, or a process that you weren't able to do otherwise, right? And you've seen from the case studies and the spoiler alert, that's how you should be thinking about additive, right? It should be doing new and unique things for you. All right, but let's unpack that again a little bit as to why, right? And so let's start just with the cost structures of additive compared to some of the traditional manufacturing, right? So this is a chart that's kind of shown in the additive world. I'm not sure how much in your worlds you've seen this, but if you look at this chart, so along the x-axis, you sort of start with quantity 1 on the left, and then high serial production all the way to the right, and the cost per part is the y-axis. So let's talk about injection molding as a comparison other here, right? So injection molding, what's beautiful about it is highly repeatable and efficient at scale, right? But it costs a lot of money to get into it. Once you design the part, right, then you have to design the mold, you have to mill the mold, you have to polish the mold, you have to get it into your press, you have to set your temps and your pressures, and then and only then are you producing parts, right? But once you do, you're producing them at dollars or pennies per part. Right, now the advantages of additive are a little bit different. You've heard some of the folks today talk about that. Right, in additive, once your part design is done, and again, these are generalities, right? Because as Brian talked about, there are a lot of complexities depending on the quality in the system, right? But once you have your part design done, in effect, you could be minutes from initiating the production of your very first part, and the relative entry cost is low. But historically speaking, a lot of the costs associated with additive tend to be variable. All right, these are not 6 seconds, 20-second cycle times like injection molding. These are hours and hours of print. And we've talked about today, you've heard people talk about, you have to touch every part. You either have to excavate them out of powder, bathe them in chems to get them to be handleable. You have to remove supports. There's a lot of touching and post-processing that occurs. So you don't see some of the efficiencies at scale that you've seen historically with injection molding. And so that drives kind of this whole discussion around, well, where is the crossover point where it becomes more effective to use traditional manufacturing than additive? And I would argue that today, it tends to be relatively low, right? Ones to hundreds. And that's why you see some of the applications in some of these high mix, low volume, or manufacturing engineering. Now, I would argue, right, that this is today, and I've got 3 points of good news for you, around this, right? And so let's talk about that. So good news number 1 is ones to hundreds happens a hell of a lot in any product development life cycle, right? So certainly it happens in design and development, right? And that's where additive grew up. It grew up, it was called rapid prototyping for decades before it became, additive, before it became 3D printing, right? So it shines there. It certainly, can also shine ones to hundreds, right? And that bridge element, right, between sort of your design and development, your bridge parts that are required before, your first run of production, before your steel tool is up and running. Andy showed a lot of examples of ones to hundreds out on the manufacturing floor. Right, so manufacturing engineering, another great example of ones to hundreds. If there are any kind of supply chain interruptions, or on a lot of these new products, right, the demand is unknown, right? It can be very volatile. And certainly in obsolescence, right, as you're trying to manage the supply chain, oftentimes you're required to have a lifetime buy of those components. Or, if it's an aged component or an aged system that you're required to support out in the market with service and warranty, hopefully you still have, the tool, and if the tool wears, you've got the drawings to recreate those parts, right? So there are a lot of areas through a product life cycle where ones to hundreds, and additive can support you with really cost-saving applications. And you can enhance, right, the part for part cost structure by better designing for the process itself. And you should absolutely do that. But I would argue, just like the keynote that we had, you really should be moving in the same as there are opportunities beyond a plant perspective, right, for digital manufacturing into a fleet perspective. There are a lot of opportunities in additive moving from a part perspective to a assembly or system perspective. It unlocks two whole value streams for you. And you've seen some of the design goals that are represented in this in the case studies in the previous two. So the first is in your cost to manufacture, right? So granted, these are all over the board, right? So I just kind of picked a weighted average and Greg's best guess. But let's just say the parts themselves in your cost to manufacture your good represent somewhere around 35%. All right, all the rest of it is in assembly, it is in labor, it's in overhead shipping, whatnot, what have you, the rest of it, right? And so there are a lot of design goals that additive can help you achieve to attack the green part of this pie chart. And we talked about some of them. You can combine different parts into singular print and assembly, and that eliminates a lot of points of labor. It eliminates points of failure, which will translate, into service costs. And don't forget about the hidden administrative cost of every SKU in your BOM, right? I mean, managing POs, QA, QC, inventory, all of that costs money. And so combining parts into singular components together is a significant cost savings. That was a lot of probably what was behind the economics of some of the case studies that you saw earlier. Lightweighting and reducing just the material used. And then frankly, again, a lot more new products coming to market. You never get them exactly right the first time. There are engineering change orders that are stacking up in the first year or two of new product development. And additive and not having some of that inventory be stuck in a steel tool allows you to take advantage of those and bring those to market. There's a reason the engineers need and want to make those changes. There's value to you and your customers, right? And the second cost stream is your customer's cost to own. So let's just say that 45% kind of on average is kind of what your customers' part costs are in their total cost to own, right? And so if you're thinking about additive on just a part for part basis of a different manufacturing technology, the same part in CNC or IM, and I just want to make it an additive, you're really only thinking about 10 to 15% of the cost that your customer cares about. Right? Now that's impactful, but it's not anywhere near the full value that you can bring to them, right? And so you can have more organic shapes in the freedom of design that improve the operating performance. That was one of the examples that was brought up. You can reduce the total overall operating costs with fuel and utilities. You can extend the life, right? So your reduced service costs are their reduced maintenance. And you can enable them to generate entirely new revenue streams via customization and the freedom of design and the design variability that additive enables, right? And so new streams of revenue and profit is always good news. And I would say the third part of good news is that the industry is not staying static, right? We recognize that production is a critical need that we have to support. When we go to the Additive Manufacturers Users Group or Rapid or Formnext industry events for additive, production is the number one topic of conversation. And I would argue, I'm going to go through the slide really fast because Will actually touched on quite a bit of this in his intro, but I would argue there's four forces that are converging to enable more production applications for additive. And the first is economic efficiencies, right? Will touched on this. We've got to get the machines to be more OEE efficient, right? And build faster. And that's why some of these binder jetting and getting away from these single point scanning systems, be there a single laser or a single extruding head, right? A lot of people are getting away from that. And if you can't binder jet to resolve an entire layer at one time, people are either going to multiple heads or multiple lasers, right? Getting the layer time and the overall print speed down. We're talking about going to open systems, right? And those open systems help in part to borrow scale, right? So, one of the new entrants is talking about using MIM-based powders, right? And that gets the cost down from some of the traditional additive powders sizably. But the other thing that it does is it's going to enable technical advancements, right? Remember with injection molding, it took machine materials and applications. And there are just too many trade-offs today, especially on the plastic side with the material properties to enable full-scale production. And so, these open systems, folks like Dow, BASF, Evonik, Henkel, nearly every chemical or adhesive company is now entering additive. And I would say that's only happened in the last 3 to 5 years, right, at any substantial scale. And so the amount of investment and science that is behind some of the, the material advancements is going to be huge. And frankly, that's not a knock on some of the historical, material providers. They've done a great job. But that's only a handful of those folks, right? And so I think this has a lot of people in the additive industry very excited. We'll touch on a design adoption, right? It is extremely difficult to step back from a part versus part comparison into a system or assembly comparison if you're way down on your design stream. I mean, it's nearly impossible to go back and redesign after the fact. It's extremely challenging. And so we got to have additive as a manufacturing option up front when you're considering the design from the get-go. We show some of the topology optimization that's already been showed. I would also argue that some of this is just going to naturally take its course, right? Young engineers coming into the marketplace today, it is likely that the very first manufacturing technology they were ever introduced to was additive. My daughter's a junior hire, and she's had robotics and 3D printing since elementary school, right? And so some of this is going to take care of itself naturally. And then finally, infrastructure, right? We've got to have more robust infrastructure out there, right? There have to be people that are willing to make the investment, folks like Proto Labs, like Centavia, like Eckhart, right, that are production ready and able to support, right? There are just not enough robust infrastructure out there. And frankly, that infrastructure has to be building to more common standards, right? Right now, there are a lot of different processes and approaches that people take from a supply chain perspective. That's variability, AKA risk. And so I think a lot of us in the industry realize that there has to be more formalized standards. There's a lot of discussion around that. So I'm going to take you through 2 very quick case studies about folks that have been able to do this today, right? So I would argue, don't wait for the industry to kind of push this thing forward. It's got to be a push and pull. And here are a couple little examples, of folks that have done this really well. So one is Invisalign. And I like to use them because I think a lot of people kind of stand back and say, they 3D print their aligners, and it's really cool. That's not what they do. And so I want to talk you through the full case study and exactly what they're doing. So it starts with a digital treatment plan. So it's a 3D scan of their patient's teeth. And then what the clinician does is they take from the current state to the desired end state and the iterative steps that's in between, right? So you wear an aligner for a few months, you throw it away, you put on the next aligner, and it gradually, kind of like going in the old world of having your braces tweaked, it kind of gets you to this ultimate end state. So once the patient and the clinician approve that plan, they push it forward and it goes into their production. So again, digitally pushed forward into production. Once in production, what they're 3D printing are the molds. All right, so they take those 3D renders of the successive steps of treatment and they print a 3D printed mold. And they're printing hundreds of thousands of these daily. And that's, believe me, that's big in its scale. But the new thing that they're doing, right, that 3D printing enables the full digital manufacturing is they're printing a QR code on each of those different 3D printed molds. And when then they go to overmold, right, of the biocompatible material on top of it, it reads that QR code and it prints then a recognition label on the biocompatible aligner itself. So then, now it's molded onto a plate, right? When it goes into the milling step and the trimming step, it reads that label and it automatically pulls up the G code that enables the trimming step on it. And oh, by the way, those plates are RFID enabled. And so they know where any of them are in the facility at any given time. And that's how they get a complete set back together in the right order and shipped out to the customer. And so that's a really cool example to me. Again, they don't just 3D print their aligners. What they use is 3D printing to enable fully digital manufacturing that enables customization, an entirely new revenue stream that wasn't available to them without that critical step of additive in between. So this is how you can think about additive enabling customization. And then not present here today, but we were invited in by Velo. And I'm not going to touch on this a lot because I think we've heard a lot of some of the examples of this, but we can't really talk to the case study, and so I would have to speak in very general terms. But the parts we're making for our customer are very much like these, like shrouded impellers, heat exchangers, manifolds. So they're very complex parts. Anytime you're managing fluid flow, be that air, water, coolant, you really want as organic of a flow as humanly possible. And if you were going to make these historically, right? So with traditional manufacturing, you'd have to make multiple different parts and assemble them in some way. If you were going to use conventional manufacturing, often you're making some of these trade-offs, right? So conventional additive, Brian even talked about it. You got to deal with supports. You got to deal with some of the orientation trade-offs. Each of those create different stress within the parts and create some challenges back and forth. And what this Velo, and again, this is an example in what I'm talking about. This is an example of having more efficient parts printed, and usable right off the printer. And so Velo has kind of a unique laser method that they use, and they do in situ adjustments to kind of help manage the stress. And what that allows them to do is print with low to many times no supports whatsoever. And so rather than making any kind of orientation, support, or design trade-offs, you get the optimum design right off the printer the first time. And again, can't really talk to the exact case study, but I can tell you that the parts that we're making for our customer can only be made on this system. And there are significant cost savings against both conventional, additive and traditional manufacturing. All right, so I'm going to wrap up here with kind of my rules of thumb for additive and how you should be thinking about it and incorporated it into your products and your manufacturing. So one, it is not a replacement. All right, there will always be a role for the traditional manufacturing steps. Especially at really high quantities, right? I mean, especially in the near term, right? But this is another tool for you to use. Think about additive in some of those lower volume applications, be those manufacturing engineering or product development. Understand that there is much value to be found in system and assembly level design thinking. But with that, you have to recognize that a lot of the benefit that your company is realizing will cross budgets of functions within your organization. And so you have to have a P&L view. If you're looking at just with your supply chain or just with your engineering team, it's going to look like additive business cases are not paying out when in fact they're generating significant amount of value for you. They're just at different P&Ls and budgets within your organization. All right, so if you're brand new to it and you got the challenge of go figure out how additive can work for us, I love this quote that one of our founders of our additive business had. If your parts are hard to make, so where should you look? Look for parts that are hard to make today, right? Because they're probably good candidates for additive. But if your optimum design is impossible to make any other way, that's the perfect candidate for additive. So that's what I've got. So I appreciate it. Thanks so much.